Hello students, last time we finished theorem 7.4 and 7.5, which was side congruence and RHS congruence. So today we will start exercise 7.3 and we will do question number 1 from it. It states a triangle ABC and triangle DBC are two isosceles triangles on the same base BC. Vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, show that there are four parts. The first part is show that triangle ABD is congruent to ACD. Second part, triangle ABP is congruent to triangle ACP. And third part, AP bisects angle A as well as angle D. And fourth part is AP is the perpendicular bisector of BC. We will do each and every part one by one. Let's first understand what is given to us. It is given to us that triangle ABC and DBC are two isosceles triangles. So that means this triangle AB and C, this is an isosceles triangle, as well as this triangle DB and C. This triangle is also an isosceles triangle. And we know about isosceles triangles that they have two equal sides. So same will be case over here. These two triangles will have equal sides. And in this triangle, this side AB and this side AC is equal. So in triangle ABC, side AB and AC is equal. And in triangle DBC, side DB and side DC, they are equal to each other. So this was a given. Now let's start by doing a first part. And what was the first part? Was that show that triangle ABD and triangle ACD, they are congruent to each other. I have given these two triangles over here. You can see that I have written down triangle ABD in a red color and triangle ACD in a green color. We have to prove that these two triangles are congruent to each other. Let's prove them. As first said that in triangles ABD and ACD. So triangle ABD and triangle ACD. AD equals to AD common. This side over here, this side AD, you can see that this side AD is a side which is present in both the two triangles. That means it is a common side. And I wrote down AD equals to AD a common. So it is present in both the triangles. Also, AB and AC are equal. Yes, because it was isosceles. Here, AB and AC, it is an isosceles triangle. That means the two sides will be equal. So I wrote down AB equals to AC because triangle ABC is an isosceles. Similarly, triangle DBC, which was a smaller triangle, this one, triangle DBC, this triangle is also an isosceles triangle. That means this side BD and this side CD, they will be also equal to each other because two sides of an isosceles triangle are equal. So I wrote down BD equals to CD because triangle DBC is an isosceles triangle. So in these two triangles, we have proved that three sides are equal. Therefore, they are congruent by which condition? Yes, SSS congruence condition. So we have done our first part. Now let's move on to the second part. Second part states that prove that triangle ABP is congruent to ACP. Here it is. ABP is congruent to ACP. So these are the two triangles. This is A, B, P, and then again A, C, P. Yes, these two triangles, we have to prove that these two triangles are congruent to each other. Now let's do it. So I started by doing this. In triangles ABP and ACP, AP equals to AP common. You can see that this center side, this one, this is a side present in both the triangles. That means AP is a common side. So I wrote down AP equals to AP a common. Next I wrote down angle PAB equals to angle of PAC. Let's see which angle is this. This angle is PAB and this angle is PAC. Now why is it equal? if you look at the previous triangle, you'll find that this angle and this angle, these angles are present in congruent triangles, and we know that if triangles are congruent, then all other corresponding parts are congruent to each other. We call this as CPCT. So if we prove that these two triangles are congruent, then these two angles are also congruent to each other. And so I wrote down it over here. Angle PAB equals to PAC, because triangle ABD is congruent to ACD and CPCT. Next is AB equals to AC. We have seen this. AB and AC are equal because triangle is isosceles. So this side AB and this side AC, they are equal to each other, and the reason is they are isosceles triangles. So we have given that in these two triangles, one side is equal, one including angle is equal, and one other side is equal. That means the congruence condition is the triangles are congruent by side angle side congruency condition. Now let's move on to third and fourth part. Third part states that you have to prove that PAB, this over here, this is the triangle for the third part in here, and we have to show that angle BDP equals to angle CDP, which can be also put as AP bisects angle A as well as angle D. So first let's have a look at angle A and D. Where are they? So this is angle A and this is angle D, and you can see that AP is a line, this line AP passes through both angle A as well as angle D. We have to show that this line AP divides angle A and angle D into two equal halves, and that is what is called as bisecting an angle. So now let's do it, and we have a figure for it over here. I said that angle PAB equals to angle PAC. This angle PAB, and this angle PAC, they will be equal to each other. You can tell me why? Because we just proved that these two triangles are congruent to each other, and if triangles are congruent, then all their parts are equal. That implies these two angles will be also equal to each other because triangles are congruent, because this triangle and this triangle, they are congruent triangles. These two parts will be equal to each other, and the reason is CPCT. So I wrote down PAB equals to PAC and CPCT because these two triangles are congruent. ABD and ACD are congruent to each other. Now, if it is getting divided into two equal halves, what can I say? I can say AP bisects angle A. That is, AP divides angle A into two equal halves. Now, the other portion of it, which is we have to show that it also bisects angle D. Angle D is getting into two equal halves. So I wrote down that in triangle BPD and CPD, this over here, this is the triangle BPD and CPD. PD equals PD because you can see that this is common. This side PD is common in both the triangles. It is a side present in both the triangles, so it is common. So I write down PD equals to PD. BD equals to CD. This side BD is equal to this side CD. Why? Because the triangle is isosceles triangle. It was already given these two sides are equal. So I wrote down BD equals to CD because triangle DBC is an isosceles triangle. And BP equals to CP. This BP and this CP is equal. Why? Because if you look at this triangle, this over here, I have proven that these two triangles are congruent, and when triangles are congruent, then all the corresponding parts are also congruent. That means this side and this side will also be equal to each other, and the reason will be CPCT. So wrote down BP equals to CP because triangle ABP is congruent to ACP, and the reason is CPCT because they are congruent triangles. So we have shown that three sides in these two triangles, three sides are equal. That means they will be congruent by which condition? Side, side, side. Therefore, triangle BPD is congruent to CPD by side, side, side congruence condition. Okay. And if triangles are equal, can you tell me what about these two angles? This angle over here and this angle over here. What about these two angles? If triangles are congruent, then all their corresponding parts are congruent. That means the two drawn angles I've just drawn will also be equal to each other, and the reason will be CPCT. So say that angle BDP equals to CDP. The reason is CPCT, because I proved they are congruent and these are corresponding parts of congruent triangles. So when it gets divided into two equal halves, that means it is getting bisected. So I can say that the line AP, but this line AP bisects angle D as well. So in general, we can write down that AP bisects angle A as well as angle D. Now let's move on to the last part. The last part says that you have to prove AP is the perpendicular bisector of BC. There are two things in it. One, you have to show it is perpendicular, and second, you have to show it is the bisector outer side. Let's first see where is AP. This line is AP. Let me draw it first. This line is AP. Yes, you can see that this line. And this line is line AP. First, we have to show that it is a perpendicular. That means we have to show that this angle over here or this angle over here, it is 90 degree. 90 degree. So we have to show it is a perpendicular. Secondly, it is a bisector. What does bisector mean? Bisector means it divides the side through which it is passing into two equal halves. That means we have to show that this side BC is getting divided into two equal halves, or we have to show that this PB and this CP are equal to each other. These two parts are equal. Let's do them one by one. So this is our fourth part. Here, it starts from here. Angle BPD is equal to angle CPD. This angle BPD is equal to this angle CPD. Why are they equal? Because we proved that these two triangles are congruent to each other, and when triangles are congruent, then all their corresponding parts are equal, CPCT. So I said that BPD is equal to CPD, and the reason is CPCT. Also, BP is equal to CP. Why? Because triangles are congruent, and when triangles are congruent, then corresponding parts are also congruent, and these are corresponding parts. That means these two sides will be equal to each other. So BP is equal to CP. That means AP is bisecting it. It is actually bisecting it. It is dividing this into two equal halves. But the thing is, we have to show it is bisecting it as well as a 90. We have not shown a 90 yet. So let's show the 90. Let's see how it is a 90 degree over here. I said that angle BPD plus angle CPD equals to 180 degree. Where are these two angles? Here it is. This angle is BPD and this angle is CPD. I said that their sum is a 180 degree. You can call it as a linear pair, or you can write down, because BC is a straight line, their sum will be 180 degree. Now we know that these two angles are equal. We just wrote down these two angles are equal. So what I can do is I can keep BPD as it is, but instead of this CPD, I can write down BPD, because these two angles are equal. So what I have done is I have changed the value of angle CPD to angle BPD. Why? Because they are equal angles. They are equal. I already proved CPCT. So I wrote down BPD as it is, unchanged value. But for CPD, I change its value to BPD equals to 180. So BPD plus BPD gives twice angle BPD equals to 180 degree. So transposing 2 on this side, it will give me angle BPD equals to 180 degree by 2. 180 divided by 2, and we know that 180 divided by 2 is a 90 degree. So that gives us angle BPD is equal to a 90 degree, or we can say that we can say that this angle is BPD is a 90 degree. So it is dividing side BC into two equal halves. BP and CP are equal, and it is also perpendicular to BC. So it is perpendicular as well as bisector. That is, AP is a perpendicular bisector of BC. Hopefully you understood this. Thank you.